Okay, so our first lesson today will be pressure as a function of debt. Okay, let's watch this video and see. Okay, notice how as you pour more water into the hole, ultimately increasing the depth of the water, the pressure increases as well. But let's make sense of this answer, shall we? Looking at it mathematically. Okay, so as we discussed in class, we know that pressure is equal to the pressure of the fluid times the height or depth of the container times g, which is the constant gravity. As we can see in this relationship, h is directly proportionate to p. So as the depth increases, so will the pressure, which makes sense. The next lesson we will study will be pressure as a function of density. So notice how as you increase the density, the water not only gets darker, but the pressure increases as well. This is because, as we've learned, density equals mass divided by volume. As you increase the density, you are ultimately increasing the mass. And by increasing the mass, you are increasing the weight. By increasing the weight, you ultimately increase the pressure. This works vice versa. Notice as when you decrease the density, you also decrease the pressure. Next up, we're going to study pressure as a function of gravity. Let's go. Notice as when you increase gravity, you also increase the pressure. This also works when you decrease gravity, it also decreases the pressure. This shows that they are directly related, which we should expect. But let's make sense of this answer. We're back with our pressure formula again. But not only is gravity directly related to P, we should also make sense of this. Gravity is a force that is pushing down on the water. So as that value increases, so will the pressure of the water. The same makes sense vice versa. As you decrease the amount of weight pushing down, then the pressure will decrease as well. Okay. Now we're going to discuss the differences between the atmospheric pressure by comparing gauge and absolute pressure. Notice as when you turn the atmospheric pressure off, the pressure becomes zero. This is because, as we learned, atmospheric pressure is the pressure a person feels due to the atmosphere weighing down on a person, or in this case, the water. As you turn the gauge environment on, the pressure in the water decreases because there is less weight pushing down on the water. When you turn the atmosphere back on, or insinuating absolute pressure, the pressure goes up because there is more weight acting down on the air and the water. Next, we're going to head over to 9-3 and discuss the continuity equation and how it applies to the video. Okay, so we know that the continuity equation equals A1 times V1 equals A2 times V2, meaning that it will be constant throughout the entire time. Notice as when you increase the area, the speed decreases. The same is if you were to decrease the area, then the speed would increase, so that it would remain constant. Once again, I just want to show this to make sure we have this down. Notice as you decrease the area, the speed increases. And this makes sense because the equation states that A1 times V1 equals A2 times V2. So as one of the components decreases or increases, it will do the opposite to the other side. Let's recap quickly. Okay, we know that Bernoulli's principle states how the pressure in a fluid decreases as a fluid's velocity increases. Now, this may be counterintuitive, so let's look at the video to see how this makes sense. Okay, so we learned earlier that as the area decreases, then the velocity increases. So notice as the pressure decreases with the area. Now, vice versa. If you increase the area, then the pressure increases as well. This shows Bernoulli's principle. But now think about this. This makes sense because that means that as you increase the velocity, it means that you are increasing the force in that direction. So the pressure will increase as a result. Okay, I hope you enjoyed my physics lesson for the night. Remember to check the Moodle, Mr. Howell, because we have a homework assignment due tomorrow. And if you don't check it, I'm not accepting late homeworks. We also have a test coming up in a few weeks, so remember to study for that, and you can use this as a helpful guide. Alrighty, I will see you tomorrow in class. Have a nice day.